Okay, so discounted payback period. So, so now we're shifting. How long does it take the project to pay back its initial investment, taking into account the time value of money? Uh, Decision rule, except if the project pays back on a discounted basis within specified time. Generally, with the projects we'll be talking about, it will be within the life of that project. So, and so by the time you discounted the cash flows and so forth, you may as well just calculate the NPV. So it's actually it's especially if you're doing it by hand, it's a much easier calculation to calculate the NPV than to go through all the iterations required to calculate the discounted payback period. Internal rate of return. So internal rate of return is the discount rate that sets the net present value to zero. So acceptance criteria, except if the IRR exceeds the required rate of return. Ranking criteria, select the alternative with the highest IRR, internal rate of return. Reinvestment assumption. We assume that all future cash flows are reinvested at the IRR. This is a flawed assumption because it may or may not be possible to reinvest. There may not be other projects available that achieve that IRR. So disadvantages, does not distinguish between investing and borrowing. May not exist. There may be multiple IRRs. So if we have a cash flow that has multiple negatives. So say we had a project that took 3 years to build, so it would have negative cash flows for the first 3 years, and each one of those would produce an additional IRR. So it which do you choose, so forth. That creates significant problems. If a project had disposal costs, so say we had to pay to dispose of some sort of a piece of equipment after we use it for 10 years, that again would create an additional IRR. There can be problems with mutually exclusive investments. So, advantages. It's easy to understand and communicate. So it's very popular in the corporate world, but it probably is because a lot of folks that use it don't necessarily understand it. So IRR example. So we got this project. It's got a $200 initial outflow, and then $50 in revenue the first year, $100 revenue in the second year, $150 in the third year. Then, so the internal rate of return for this project is 44%. So in Excel, it would be equal IRR, and you would literally just highlight this whole. You would enter these in 250, 100, and subsequently 150, and then they would all enter in there. There is a opportunity for a guess in there, but it's unnecessary. So, but anyway, if you do so in Excel, it should be 19.44%. You can also use the cash flow function in your calculator as well. So, but the way the logic works in Excel or your calculator, what you're doing is we're determining the discount rate that will bring back all these cash flows or discount all these cash flows back to the point where they're equal to the initial outflow, or the NPV is zero. So we can do an NPV graph. So compare it with the discount rate. So and then we can also see the IRR as a intercept here. So we've got this. We basically graphed this chart over here. So our IRR or discount rate of 0%. The NPV is 100. And then that goes down all the way down here to negative $66.82. The IRR crosses right here at zero. But the Excel is very efficient at creating charts and spreadsheets like this. So if you have any questions about them, feel free to ask me. So calculating IRR with the spreadsheet. So you start the same cash flows as you did for NPV. They use the IRR function that I mentioned. The first thing you do is you enter the range of cash flows, and starting with the initial, and then you can enter a guess, but you do not have to. So the default form is whole percent, which you do not want to increase the decimal places to. You would normally want to increase the decimal places to at least 2. But I'm not going to pull up that spreadsheet, but I'll go back to our the spreadsheet we were looking at. So let's go here. All right, so I can just do this. So equals IRR, open parentheses, and I come up here and just press select there, and I can drag it across, and then I hit shift and close the parentheses and enter, and that's 16%. And I can add a couple of decimal places up here. So 16.13%. That's as simple as that. So on your calculator, you enter the cash flows into your cash flow function and hit IRR compute. All right, so let's go. So problems with IRR. The multiple IRRs, as I mentioned, the borrowing or lending, the borrowing rates and reinvestment rates can be totally different. The scale problem, depending on the size of the project, it can lead you to a false positive decision or so forth, or selecting the wrong wrong project, timing problem. So we'll start the next lecture with mutually exclusive versus independent.